And Greg, up to you.
All righty. Well, in true confession, last night as I was getting my Hunter Orange and my gun out and setting it out for the morning so that when I get up early to go hunting, I realized that this was this morning. So, yeah, I didn't actually plan it that way, but I'd rather be here. So let me see if I can share content. And if I do, y'all tell me. All right. Can you see that?
We do. We see amateur radio satellites.
All right. So I'm going to kind of go through this faster. It won't be fast, I guess, but it'll be faster. But Greg has a copy of the presentation. So if any of you want it to look at it a little closer, you're welcome to do that. Just get hold of Greg and he can help you out. And other than that, I'm going to go ahead and get started. So this is my current VUCC map. The United States is broke up into 488 grids, and I've worked all of them now except 4. I've got 1 on the West Coast and 3 on the East Coast to go, and there's some hard grids. That FN 55 in the upper corner is actually on Sunday, and I'm going to try to get that one Sunday. But if you're into satellites, you've got to stay within 200 kilometers of your home. It's called your VUCC circle. And then you work these grids all over the country. And that's taken about 2 years to get to that point. I wanted to include 2 pictures. There was a rove that just took place. A rove is when somebody goes remote, kind of like a de-expedition. They went to DL88. There's about 100 acres of land that's in South Texas, right on the Mexican border, the Rio Grande. There's no roads within about 80 miles of it, so it's all 4-wheel drive, outback access. But these 2 guys, N6UA on the left and Ron 80DX on the right, activated that, and I was able to get that grid from them. So we're going to cover a little bit about the satellites and then focus in on equipment and how to find the satellites and track them. And can you still hear me okay?
Yep, fine.
Okay. One plug, or there may be a couple in here because AMSAT helped, but there's an organization called AMSAT. And it's a group that's been around for a long, long time. They work directly with NASA and the space agencies. It's amateur radio getting satellites into the air, and AMSAT's worldwide. Anybody that really wants to learn more and do more, you need to get on the AMSAT website, amsat.org. And there is just a plethora of resources on that website. I belong simply because they're putting satellites in the air, and I enjoy working them. The vision for the AMSAT is to get satellites into space, low Earth orbit and high Earth orbit. Right now, almost everything we work is low Earth orbit, and the footprints are smaller, obviously, because they're closer to the Earth, and they're not stationary. They actually circle the globe, and so you get 5, 10, 15-minute windows to work these satellites. Europe has launched a stationary satellite earlier this year, and so they actually have one that's kind of sitting over them, which would be nice. But anyway, AMSAT's wanting to get into high Earth and even stationary in the future. There's a whole bunch of satellites when you get researching it, and these are the main ones that are operational. Interestingly, AO7, which is by far the oldest, launched in 1974 when I was 14. It's still operational. It had gone silent, came back to life, and right now you can work it with about 5 watts of power. You work it with much more than that, it'll flip it, it'll turn it off, and it has to go into darkness to reset itself. But it is one of the largest footprint satellites that we have and is still operational. RS-44 is another very high satellite. It's the one I hope to get this guy on Sunday from FN55. It's got a big footprint. You guys could easily work Europe, Spain, Africa, parts of Africa with RS-44 from Tifton, as well as using AO7. There's two satellites that traverse east to west across the country, and that's CAS-4A and CAS-4B, very easy satellites to work. And then the XW satellites, also very easy to work. All of those that I just mentioned are linear. You work them single sideband, and there's a 10 kilohertz, give or take, bandwidth. So you can have 3 or 4 conversations going on at once on those satellites. The FM satellites are a little different. It's one and done. You can have one person talk at a time, and if 100 try to talk at a time, it's just a buzz. AO91 is the main one. SO50 is the main one. And then you have AO27 that's on for about 3 minutes when it passes over. The International Space Station a month ago just activated a new repeater. So it's not just a digipeater. They'll turn it on and it'll actually be an FM repeater. And then PO101 is I think a Chinese satellite that they've turned on for COVID for amateur radio use, and it'll go away one day. But we'll have more to say about those in a minute. Just kind of an overview. These satellites are 10 by 10 by 10 centimeters or 4-inch cubes, kind of amazing. Low Earth orbit, 600 to 800 kilometers. They're kind of elliptical orbits. Single channel FM transponders are UV, so upload U, ultra, and V, download VHF, so UHF, VHF. The Fox satellites will have L-band modes, and they're pretty low power. They're tumbling in space, so their antennas fade in and out as they tumble, and kind of amazing creatures. Coming up, at any time, we're hoping that they're going to launch a Fox 1E. It's it's like the CAS-A and CAS-B satellites, but they've taken learnings from failures, and it's supposed to be a pretty neat satellite. You've got the Golf T, you got the Golf. I'm not going to go into these. AMSAT just did a presentation about 3 weeks ago that was on Zoom, where they went into infinite detail on these satellites. If you're interested, go to the amsat.org website, look for the annual conference that just happened in October, and watch that presentation. There's one on there on the upcoming satellites, but some of the new ones coming are going to have multiple modes of operation. Like I said, it'd be good to join AMSAT if you want. So I'm going to give a caveat at the beginning. Are any of you working satellite? Wayne, I know you were trying a year or two ago. Is anybody trying to work satellites?
I do quite a bit of telemetry gathering from 71.
Cool. I think Wayne was doing some, and we had some stuff. He'd contacted me about a year and a half ago, and we had some stuff come up in our life that kind of took me off ham radio for a while. And I need to get back with Wayne at some point and see if he's still trying that. But the neat thing about satellites is you can get in for as cheap as you want, just about. One thing that I wanted to mention now and get it out of the way, with COVID, it seems like hundreds, if not thousands, of people have decided to work satellites. And the entry point in FM satellites is $30. It's a Bofong radio, preferably 2, so you can hear the up and the down. But that has brought a ton of people onto satellites. The problem is that if more than one person transmits, it'll jam the satellite. And what's happening, people have figured out if they use more than 5 watts, they might get in. Well, it's all the way up now where people are using linear amplifiers, and they're literally killing the satellites. So I listened to a pass yesterday. Not a single contact was made. Everybody was stepping on everybody. It was a circus. So just a warning that satellites are a blast. I've had fun doing it. For whatever reason right now, it can be not a lot of fun when you get on there and you got all those people acting like crazy people. But you can do it with Bofong radios. So I'm going to very briefly go through some of the radios and then how to know where they're at, how to track them, and what an exchange will sound like. I'm going to skip over this. So you really need duplex, full duplex. And a lot of radios say they're full duplex, but they're not. You need full duplex. So what's happening as you transmit to the satellite, you need to hear yourself back through the satellite. That way you know you're talking. If you can't hear yourself, you're just creating QRM, and you need to stop talking. And so it's imperative that a person be full duplex. And what you'll hear today on the satellites, people will be talking and people will be answering them, but they can't hear themselves and they can't hear the other people, but they just keep talking. So you've got to be able to hear full duplex. So that means 2 Bofong radios, one on UHF, one on VHF. Or you can get a full duplex transceiver. I use a Kenwood TS2000 in my base station, my ham shack, and it'll do full duplex. There are several radios that'll work. The radio here is the one I use out portable. I have it hooked to a mast, a little 5-foot mast with a dual beam Yagi antenna on a stick. And most of those grids I showed you, I've worked with the TH72, the Kenwood. It is full duplex. You can also use different mobile radios, full duplex. Here's a bunch of them listed. Again, I'm not going to dwell on this, but you can get with Greg and he can get you a list of what radios are truly full duplex, or he can share the presentation with you and you can look at it. And then here's some of the base stations. You'll see the second bullet, Kenwood, the 790, the TS2000. One thing about the TS2000, I had an old one sitting on the shelf. It has a birdie that interferes with SO50 and AO27. And so you cannot work those satellites with it, but you can work most of the others. So if you got an old Kenwood sitting around, it's a good one to use to work satellites. And then some half duplex transceivers. What I have recently put together, and I'm going to try to learn to use, I've put together an FT817 with an ICOM 7000, or not 7000. What is it? I forget. It's what I had in my truck. ICOM 1000. Anyway, I've put it together. Oh, it is ICOM 7000. Yeah. And so I have one on UHF, one on VHF. So in essence, it's full duplex, one to transmit, one to receive. And a lot of people use a stack like this when they're out portable or even in their ham shacks to create full duplex. You'll see on the internet videos about using either a vertical antenna on a tower or rubber duck antennas to work satellites. You can, people have. Generally, you can transmit just fine, but you can't hear. And so you'll tie up the satellite, not being able to hear. And occasionally you'll be able to hear and get a contact, but it's not the best thing to do. Really, you need to buy an arrow antenna, an Elk Antenna, make one. You can make one for $5, a little Yagi if you search the internet for satellite Yagis. I went to a ham fest 2 years ago in August and found a $30 dual band. It's about 4 foot long. It's got 3 elements of 2 meters and 7 elements, 440. And that's what I use for my my portable operation. And then I just bought an arrow antenna that I'm using on linears portable. So you can either make one or buy one, but I wouldn't be fooled by the videos on rubber ducks. So here's an arrow. This is one I just bought. It's a good little antenna. It's aluminum, uses archery arrows for elements, and it works great. I'd say 90% of the people operating satellite portable use that antenna, and it's $100. There's an Elk antenna that people use. They say it's heavy, but it's also available. Here's one made out of PVC pipe and some copper wire from VE2 Z Alpha Z, and the plans are on the internet. Here's one that's a wood stick with some copper elements. This one's the $5 antenna, VA5 Victor Juliet Bravo. Again, plans on the internet. And when you're out in the field and you're working satellites, things are happening super fast. And as long as the satellite's in the air, you're good, but it goes quick too. And so you don't have time for problems. And so this slide is just, hey, don't buy the Chinese cheap connectors. If you can buy a solid one-piece connector, you're better off than using the cheap Chinese two-piece connectors that you can get for $1 on Amazon. Because when you're in the field, like those guys in DL88, a year of planning to get there, you don't need a failure. I'm going to stop. I'm going to go into some equipment you need and why and some programming, but are there any questions?
Am I muted or not?
No, you're good.
Okay. Greg, I have the arrow antenna. And of course, I've had some things like you said going on. I hadn't been on in a while. I hadn't been on a whole lot this year, but I have worked it. Has somebody come up with the most expensive thing? I don't particularly care to get out there running around the yard with the antenna in my hand. And has anybody come up with a rotor system that would take like that? You could mount that arrow antenna on a very small rotor system instead of a $2,000 rotor system that would turn your house.
You know, there's some guys, if you search on the internet, they've built some Raspberry Pi 2-axis rotors, and it's actually active projects going on right now on Twitter where guys are talking about it. A couple of people have gone to like Sears or other closeouts where they have those really lightweight, I think Lowe's, but really lightweight TV rotors that are $30. And then they figured out how to use the Raspberry Pi to control them. So I think there's options. I've not done it. Another thing, like when I'm working linear, and we'll talk about in a minute how many hands you need to work linears, but I take a tripod and I'll have to move the antenna every once in a while, but I don't have to hold it. I can set it on the tripod, point it in the general direction, and every 30, 40 seconds, bump it a little bit to get it to move to a new location, and that works. At home, I've got a rotor that turns my HF antennas, and I've just tilted 2 Yagis at 17 degrees, and it's a 1-axis rotation. But at 17 degrees, you cover over 80% of all satellite passes in your footprint. The beam width and such that it'll do that. I don't know if that answered your question.
Yeah, it's it looks like, and I've read a few projects where people have used like stepper motors to make them. I just wondered if you were familiar with that.
Well, I've seen the articles. I haven't done it. I honestly, this winter when it starts snowing, I'm going to study because I'd like to put something like an arrow on top of my ham shack. I don't have a good horizon, but from 20 degrees up, I'm okay, but it'd be great to have a 2-axis with an arrow. But yeah.
But you're saying if I mounted one on my HF rotor and gave it a 17-degree tilt, that should get 80% of them?
Yeah, they say somewhere between 78 and 80% of all passes that are above the horizon, when you take, you know, a Yagi has so much beam width, so say 20-degree beam width. When you take that and you look at all the passes, it covers about 80% of all passes. And another thing, Bobby, if you do that, I got a retired ham that sold me 2 meter and a 70 centimeter Yagis, and it's like 15 element Yagis, which is great. The problem is the beam width of those things is so narrow, they're terrible for satellite.
Right. Okay.
So less elements, the better.
Yeah, I've got that arrow you were talking about.
Yeah.
And I've got out there with the handy talkies and made a few contacts, but that's hard on the old man.
Yeah, it is. Well, and if you stick it on a tower, be sure to figure out how to weather seal it because those BNC connectors will leak. But
okay.
All right. If any of you want to interrupt, please just feel free to interrupt. This slide shows a bunch of things, but what you're going to learn really quick, especially if you're roving, where you're the guy that everybody wants to talk to, you got to have a tape recorder. Things are happening absolutely so fast. You might work 20 to 25 contacts in the span of 7 or 8 minutes with a whole lot of chaos. So if you don't have a recorder, you're not going to be able to do it unless you have 6 hands. And so you need to figure out how to get a recorder in line, make sure it works, have a spare with you. But a recorder is the most valuable piece of equipment you could have. Your cell phone, there's some apps I'll show you in a minute, will help you know where they're at and track them. Some of the antennas require diplexers, where you can split out the signals. So you'll know if you need to do that. The little round barrel thing, that's a bandpass filter. I need to get one right now. I'm having intermodular interference on my Kenwood. And basically what it'll do, it'll block either UHF or VHF so that you can hear better. You got to have headsets. You're going to have a splitter to get your microphone and your headset working. And then you got to have, you know, of course, your microphone. And right now on my linear setup, I'm using a hand mic and I just can't do it. I don't have enough hands. So you really need to figure out a push to talk or something when you're working satellites. So trust me. Real quick, I'm going to just hit acquisition of signal, AOS. So when does it first enter the horizon? When does it come up where you could first see it, line of sight? TCA, time of closest approach, it's when it's directly overhead, or equivalent if it's off to the side, it's at the height of its arc. And loss of signal, LOS, the time that it goes below the horizon. And those are important things that you'll want to remember when working satellites. So here's some apps. I've used the first 3. The second one, GoSat Watch, is the one I use exclusively when I'm out working satellites. It'll show you when it comes up. You put in your grid square, your location, and it'll show you when it's coming on the horizon, where it's traveling, and when it sets. And it's indispensable for working the satellites. The first one, SatSat, I use that one because it has a feature that you can look up a satellite pass and then put it on your calendar. And so when I'm working like the guy tomorrow, he said, I'm going to be on these 7 satellites. Well, I've gone in and look to make sure I have a footprint and that I can work him. And if I do, then I put that on my calendar, and then my phone will remind me that the pass is coming up. So I use the first two. The other two I'm sure are great, but if you're serious about trying to work a satellite, you got to know where to point your antenna, and this will help you know where to point your antenna. Then there's a newer program out called Theodolite. Basically what it does, it's a camera, takes a picture, puts the grid square, this is DL88, JX78, the altitude, and then the coordinates down below. But when you're roving, you have to prove you're in the grid. If you're on a grid line, you got to prove you're on a grid line, and if you're on a grid corner, you got to prove you're on a grid corner. So you've got to publish that. Like on Twitter, a lot of us are on Twitter. If I activate a grid line, I'll post a picture with the satellite data that shows, hey, I was really on the grid line. So Theodolite is really, really a nice app. At home, I use Windows Sat PC 32. You can set that program up. It'll track all the satellites. It'll move your rotor. It'll cat control your radio. And so at home, I'm using that software with my Kenwood TS2000 and the two Yagis on my HF antenna rotor. And it'll track the satellite, and all I got to do is sit in a nice warm shack and talk to satellites. So it works great. It's a bear to set up. I have an issue right now I'm trying to get resolved with the PO101 satellite, and I can't find anybody that can help me. But when you get it working, it's a great piece of software. I've not used the Mac Doppler, but there are programs for the Mac users. I'm a Mac user, but
So Greg, I use Ham Radio Deluxe satellite, and that works really good for me. And I use PST rotator to control the rotor.
Greg, I know a year or two ago, there was a big hubbub. I tried using Ham Radio Deluxe Sat, and it was terrible. It didn't bring in the right Kepler elements. And did they get that fixed?
Yes, it works flawlessly now. They went through a period of time, a couple of years, that it was just horrible. It would hang up and lock up and all kinds of things, but they've corrected that now. It works really good.
Well, this winter I'm going to play with that then.
And I love PST rotor. I've actually have the Azimuth version and the AS-L version. Those programs themselves will track the satellites for you directly. I don't know if you've seen that or not.
Yeah, I use that. Long story, my rotor failed. You probably saw my post a couple weeks ago, and I had to buy a new rotor. And I thought I'd be smart and buy the Yaesu rotor controller. Well, that silly controller does not hook up to a serial port. For another $700,
Yep.
You can buy an interface for it. So right now I don't have computer control on my rotor.
Take a look at the green Huron controllers. I love them. I've got a pair of them.
Yeah, I saw that. I'm looking at that. And then Vibraplex has an interface box that goes from the Yaesu controller, and I got to decide what I want to do. All right, I'm taking too much time. Greg, you want me to keep going here?
Oh yeah, yeah. This is good. Keep going as long as you want.
Okay, so the satellite's going to come up on the left, LOS. TCA is the closest, and then AOS is when you lose it. You need to remember that when you're looking at the time charts, trying to figure out where is the satellite and what time is it going to be there. You're going to have an uplink frequency, which may be VHF, and a downlink, which may be UHF, and depending on the satellite, those are different. So you're going to, whichever satellite you're going to work, you're going to want to get that figured out. Here's the bugaboo with working satellites, especially linear. when you're standing by a train track, you hear a train go by and it's type sound where it goes high to low. Well, that's what a satellite's doing. So as it comes up, when you transmit, the satellite is hearing a different frequency, a different sound as it goes across the sky. Now, pretend that you're sitting on the satellite and it transmits. It doesn't hear any difference, but you on the Earth, as the satellite's moving, like the train is moving, you're hearing a different sound because of the Doppler. And they're equal and they're opposite. So if you're listening on one radio, you're going to have to tune, say, clockwise to continue to hear the satellite. But to transmit, you're going to have to tune counterclockwise at the exact same amount that you're turning clockwise, or you're going to lose the frequency and you're not going to be able to hear yourself. So it takes a lot of practice and a lot of skill working linear to get the uplink counterclockwise or clockwise and the other the opposite, and keep your signal where you can actually hear it. But you have Doppler. Doppler works both directions. It works at the satellite where we change, and it works on Earth where the satellite changes. So it'll come into play here in a second. So here's kind of a general reference. So for the FM satellites, right now, the only one of those 3 satellites that's operational is AO91. The other 2 have died. And AO92 died about a month ago. So anyway, we only have the one. But if you look, acquisition of signal, if you have the true center frequency of the satellite programmed in your radio, you're going to have to go minus 10 kilohertz at acquisition to be able to hear it. As it comes to the center, it'll be dead on. And as it goes to losses signal, it'll be 10 kilohertz the other direction. So, and that's on UV satellites. So that's the UHF down. Let me think. Might have that backwards, but that's the UHF signal that is changing so much. The VHF, the 2 meter frequency, changes as well, but it's a broader pattern. So usually you don't have to adjust the VHF. So there's quite a bit of adjustment that has to take place in a satellite pass. On the VU satellites, SO50, you've got to adjust the downlink frequency, which is, again, the VHF. So some satellites are UHF down, some are VHF down. You're always adjusting the VHF. I'm sorry, golly. You're always adjusting the UHF. So it'll change what you're adjusting. So let's see. Yeah, I think I'm going to skip through that. So the FM satellites, one and done, one person can talk at a time. They are easy to hear. Just right now with COVID, they're a zoo. So here's an example of how you would program your radio. Assume that you have the Kenwood TH72 like mine. It's full duplex. I would have the downlink for AO91. I'd have the downlink on VHF 145/960. It does not need to change. It'll be able to hear the entire pass. But my uplink is going to have to change through the pass so that the satellite can hear me. So at acquisition of signal, I'm going to have to be 10 kilohertz below the nominal. And as it progresses through the sky, I'm going to have to change. And so what we do is we program 5 memory channels. And remember, you can hear yourself talking because you're full duplex. So as soon as you quit hearing yourself, you move to the next memory channel. And then you quit hearing yourself, you just keep moving through the memory channels until you can follow the Doppler and you can hear yourself. That's why full duplex is so critical. A lot of people will get on a single frequency and it's like a broken clock. It's right twice a day, right? Well, if they set their uplink on 435 250, it'll be right when the satellite's overhead, but it won't hear you at AOS or LOS. It's only going to be right in the center. So you have to make adjustments or the satellite will not hear you. You will not be broadcast. And then AO92, whoops, SO50. SO50 is the opposite. It's difficult. I love SO50, but it's difficult. Your uplink doesn't change. It stays. This is different. It's backwards, but the uplink doesn't change. But what you're listening to changes. So when you quit hearing people talk, you gotta change the frequency. And anyway, it's backwards, but you learn to do it. And again, you program in the 5 or 6 frequencies, and you just use your memory thing and change it. Or you can do it with the VFO. But for the FM birds, this is the easiest way to do it. All right. I don't think I want to talk about that. I'm not going to talk about polarization, but Bobby, you said you used an arrow. The thing about doing it portable with an arrow is you can rotate your wrist, and so you can change the polarization. As the satellite's tumbling, you've got to change the polarization or you're not going to be able to hear it. When it's fixed on an antenna mast, it's just going to fade in and out, and you're going to have to live with it. But anyway, when you watch somebody working satellites that knows what they're doing, they'll be rotating their wrist as they're talking. Yeah, just a second, guys. Stop. Can you remove the bell off the door? We have a bell attached to the door when the dog wants out, and he's going nuts. All right, here's a sample, and we're getting towards the end here, but when you get on, you do not say CQ, CQ, this is WI4T. You will get hate mail and death threats. The satellite is only on for a few minutes, and there's hundreds of people trying to talk, and they're not going to put up with you. There was a bunch of hate stuff yesterday on Twitter because of this. So you want to get in and get out and be quiet. So when you're new, you need to listen. You need to get the cadence. You need to figure it out. When you finally dip your foot in, just know what you're doing. Never CQ, never blind call. If you want people to know where you're at, you just simply get on and say WI4T Echo Mike 27. That's it. And now people know I'm there. If they want to work me, they'll call me. Or if I want to work Steve, N9IP, I'd say N9IP WI4T Echo Mike 27, WI4T N9IP Echo November 60 QSL WI4T, and you're done. That's the contact. And you would both log it, hopefully in LOTW, and you'd log your grid squares, and you'd be quiet and let other people talk. That's how it works. Where it gets crazy is when you're the rover and people are yelling at you. You might have 2 or 3 people you hear at once, and so you're trying to remember the calls, you know, W4KN, K4KV, WI4T, Echo Mike 27. And anyway, it gets to be pretty fun, but that's what a pass will sound like. I have this if it'll work. This is the DL88, and we'll see if we can get it to work here.
Uniform. India 7 Uniform X-ray Tango.
Can you guys hear that?
Yeah, we can.
Okay.
India 4 Tango. Whiskey India 4 Tango from K5 Zulu.
Yeah, hopefully you could hear that. That's when I worked DL88. I was talking to Doug, which was K5 Zulu. They had a special call, and his normal calls N6UA. But anyway, you get on the sats, you can listen. It gets pretty crazy. Lots of people talking, and then all of a sudden you can hear yourself and you make a contact. It's a lot of fun.
Greg,
Yeah.
going back to polarization, would a circular polarized antenna be better than the vertical, horizontal, like the handheld you got it?
Yeah, they make two types. They make one that's it doesn't have electronic activation. That's it's got, like, there's, instead of 2 elements, it's got 4 for each band, and it's kind of circularly polarized, joggy, I guess. They also make one that you can switch the polarity. They've got electronic switching where you can switch the polarities. I have not looked at that. I've not studied it. To be really good at satellites, whoa, what's happening? You'll want to be able to switch the polarities around, but
That's the advantage of having the handheld.
that's right.
Rotate it as need be.
Yeah, that's right. I've worked almost 484 grids now, and 80 or 90% of those have been on a handheld 5-watt FM antenna.
Well, I'm impressed that you've worked that many. That took a lot of time.
Took a lot of time and a lot of luck. All right. We've covered what's important here. Let me kind of skip through some of this. So, I mentioned it before, you don't have enough hands and things are happening super quick. And honestly, when I get done with a pass where I'm the rover, my heart rate is through the roof. It is exciting. Gus, be quiet.
Gus,
Good grief. But you're doing a ton of stuff. You're holding an antenna, you're rotating it, you're talking, you're pushing the mic, you're writing down, you're looking at the frequencies, you're adjusting the frequencies. You just don't have enough hands. So the biggest challenge is management. And I've already told you this, but listen. There's a lot of newbies right now on the satellites, and we want them. Everybody wants them. But you need to really listen before you jump in. And probably the best way to do it is to make a schedule with somebody and do one later at night, like 10 o'clock at night or early in the morning, before things get really crazy. Weekends are the worst time to be on satellites. It's a mess on the weekends. All right, one other thing, PO 101s, I mentioned a little bit ago, I'm having trouble with. CTCSS, some of the satellites do require a tone, and to keep people off of them, or when they start getting crazy, people can change the tone. I assume it's the people that own the satellites, but PO 101 is one of them. It's gone from no tone to 67 to 141.3. And if you don't have the tone, you're not getting into the satellites. So just be aware that some of the satellites require a tone. On the AMSAT website, if you join, they do send you a book that's getting started with amateur satellites. If not, you need to go online and read it. It's got all the information I just covered and a lot more. You can slow down and take it at an easy pace. Get on the website, amsat.org. They have past prediction schedules, current status, satellite schedules. So you can see, like A07 will be in A mode or B mode. A mode is a 10-meter downlink and a UHF uplink, I think. B mode is UHF, VHF. So, and then ISS will change from data to school, classroom, to repeater, APRS. So the satellite schedule will tell you what is the current status. I'm sorry, the current status stage will tell you what are the current status of all the satellites. Upcoming satellite operations, if I'm going to rove down to southern Missouri, I can publish it there and everybody will know when I'm going to be there, what passes I'm going to work, etc. But there's just a ton of information on that website. All right, that's it. I'm sorry for taking so long, but I'll open it up for questions.
I found it's very nerve-wracking trying to do all of those things at one time.
It's crazy. And when you're the rover, like I have a grid line that's, by the crow fly, it's only about 7 miles from my house. And the grid is a rare grid. It's Ecomike 37. And so I'll go there pretty frequently. And if I announce that grid, it'll be an absolute circus. And like I said on FM, if 2 or 3 people are trying to talk at the same time, it's just like you with your local repeater. That doesn't work very well. And sometimes one guy will get through, but usually nobody gets through. And that's what happens on the satellite. And it's worse now. People are deciding, hey, I can run 1,000 watts. Well, it's going to kill the satellite. It's going to hurt it because the way they make these satellites is, to some extent, the power output's proportional. So if they're getting a weak signal in, they put a weak signal out. But if they get a strong signal in, they take that and they'll jack up their power. Now, the satellite doesn't have a linear and that kind of thing, but it's in space, it's cold, the batteries are struggling to stay alive, and anything that disrupts the rhythm of the satellite's going to kill it. And I think that's what happened to AO92, is people put too much power, it just failed.
What do you use for recording?
I wish I had it with me. I got on Amazon. I've actually bought 3 different recorders. The thing that you want, I don't remember, I think it's a Sony, but the thing that you want 2 jacks. You want an audio jack and a mic jack. A lot of these digital recorders, they don't have both. And you're going to want them when you're decoding, like after everything's done and you're listening to the recording, you want to hook a set of micro headphones up to that tape player, because you're going to be hearing static. You're going to be hearing 20 people. And if you're like me, your hearing's not what it used to be. So you need to get headphones to listen, but you're going to have a mic jack, an input jack, to be able to get the audio in. But I think it's if you shoot me an email, I'll look what model I have and let you know.
Okay. Like you, I've got some digital recorders, but you can't hook them up to do both, you know.
Yeah. Yeah, I ended up buying 3 before I finally got the right one.
All right. Well, Greg, that was very, very good. Anybody have any more questions for Greg this morning? Greg, we appreciate so much you getting up early, an hour earlier than the rest of us, I assume, to do this for us. The presentation was excellent. So thank you very much. Your check will be in the mail.
Just don't vote me into office, that's all.
Good to see you.
Your presentation was good, Greg, but it was probably better just seeing you.
Yeah, it's good to see you guys. I'm going to jump off after this. I've got my priorities now where I'm going to go try to put meat in the freezer, but it was good to see everybody. Thank you for letting me do it. Hey, Greg. Yes.
This Wayne, Greg said my CNA got here and she pulled a good one and got my speaker working where I could hear you. But good to see you, and take care. And I'm going to be back on satellite for long.
Well, good deal. Let me know. And it's great to hear from you. I pray for you guys often. So it's really good to see everybody.
And Greg, I quote you quite often in regard to the gnats. You probably don't remember that, but I quote you very often when you said, I don't know what you guys down here did to deserve all these gnats, but it must have been pretty darn bad. Good to see you, Greg.
Good to see you.
Good to see you, Greg.
Said hello too.
Greg.